Now, the most important thing that we're going to be doing this chapter, and this is the main thing I really harp on for people to know how to do, this is that mental math gymnastics that we're going to be working on, is these row operations. To manipulate these matrices in order to solve them, we get to do these three things. These are our three tools to manipulate a matrix in order to bend it to our will, to get it to look like the way we want it to look. So the operations we get to do, number one, we can take two rows and we can switch them. We can just swap rows around. That's perfectly fine. Reason you can do that is, see back here, these two equations have nothing to do with each other. So somebody saw these equations and they wrote them like that. Well, you can just reverse the order of those equations. That's fine. So we can we can swap rows around. No problem. We can also multiply a row by a non-zero constant. So we can multiply a whole row by something. And if you think back to equations, that makes sense. Could I multiply both sides of this equation by like 2 or 7? Yeah. And then it would just change these numbers in the matrix. Okay, if I can do it with an equation, I can do it with that row in the matrix. The last thing, add a multiple of one row to another row. Now, it might not look like this, but this is elimination. That's an elimination move. When you eliminate a system of equation, you multiply one of the equations by something to make a new equation, and then you add that to the other row, and then one of the equations loses a variable. You're like, oh, sweet. Well, we're kind of removing all that, like rewriting a new equation, and then like adding those two together, and then making a new equation off of that. We're just kind of like doing that all together in our head, and just because we only have to deal with the coefficients. So this is just elimination as a row operation. So I'm going to give you a couple examples of doing these row operations, but they've been deleted, so hang on a sec. Sorry about that. Now they're back. So why are we doing these row operations? Don't matter. Don't worry about why we're doing these row operations. Mostly right now, I just want you to understand the process of doing these row operations. So this first one is saying, I want to take row 1 and I want to swap it with row 2. Why do we want to do that? Don't matter. Don't matter why. I just want you to understand how to do a row operation before we really get into doing these row operations. So all I'm going to do is I'm going to copy row 1. So here's row 1, and I'm going to put that in row 2. And then I'm going to take row 2 and I'm going to put it where row 1 was. So 0, 2, 1. So that's what this row operation is telling us to do. Take row 2 and row 1 and swap them around. That's it. This second operation, this is the one that you're going to spend the most time on and the easiest place it is to make little mistakes. So what I want to do is I want to take everything in row 1, multiply it by 3. Then we're going to add that to row 2. Whatever we get as we move across that row, that's what's going to go into row 2. Everything else is going to stay exactly the same, because notice that I'm only spitting out something new for row 2. So everybody else stays the same. So what I usually like to do is, if you have multiple colors, this works great. No, don't do pen. I don't know, if you had a different marker and you're working off a whiteboard, that's nice. But I like to use one color for something that I'm just copying and another color for when I'm actually doing a row operation. So the row operation, I've got 4 spots I got to do something. I got to do 3 times something plus something else. And I got to do that for each one of these spots because I got to go all the way across the row. So I'm going to write out for the things I'm going to do. 3 times something plus something else. And I'm not going to be able to get them all in order. Sorry. Something else, 3 times something plus something else. Okay. So I want to take things that are in row 1. So these are all the things in row 1. That's the first thing I got to do. That's going to get multiplied by 3. That's 0, 1, and -2. Then I want to add that to the stuff that's in row 2. So these are all the things that are in row 2. 3, -1. And these would be like kind of continuing off, but I'm running out of space. 2 and 3. So let's just figure out what this equals. And again, why are we doing this row operation? Because I told you that's why. In the future, you're going to be deciding what row operations you're going to be doing. Just trying to show you the process. So I'm doing 3 times something in row 1, which is -1, plus 3. That's what I wrote right there. So that's -3 plus 3, so that's 0. Do it again for the next spot. 3 times something in row 1. Well, we've already done the first one, so let's go to the second one. So that's 0 plus what's in row 2, -1. So 3 times 0 is 0 plus -1, -1. Do it again. We got to go all the way across the row. 3 times something in row 1. Well, we're on the third column now. So 3 times 1 plus what's in row 2? Oh, that's a 2. So that's 3 times 1, which is 3, plus 2 is 5. So 3 times something in row 1, which is -2. That's what we wrote. Plus something in row 2. That's 3. So that's -6 plus 3, that's -3. Now the goal is you do all of this in your head. I'm not expecting you to write this out every time. If there's a tricky one that you're working with, yeah, write it out. But the idea is that you're doing all of these calculations in your head. You'll write out the row operations that you're going to do so that when you make a mistake, because you're inevitably going to make a mistake, don't get bent out of shape about it. Just say, hey, yep, I made a mistake. Cool, now I got to go find it. It's going to happen. I do it all the time. Don't worry about it. But you want to write out your raw operation so you know what were you trying to do in this step so that you can recreate it, run all the numbers through your head again, and make sure you did them all correctly. Also, watch out for copy errors. It's really easy to have like this -1, and then you come down here and you write it as a +1. It's really, really easy to do. Yep. The last thing I'm going to leave you with is, okay, so we know how to move row operations. How are we trying to solve them? We first try to get them into row echelon form. Row echelon form is a very fancy way of saying we have a diagonal of 1s and everything below it is 0. The way we're going to get there is we start up here, and the book talks about it like a staircase. You walk your way down the stairs. So you take care of this whole column first, get that to be a 1 and zeros below it. Then you move down the staircase and you take care of this one and get zeros below it. And then you can move down to the next part of the staircase, get a 1 right there and zeros below it. You don't care about what's going on above the staircase, just working your way down the staircase. That gets you in row echelon form. However, that's not going to solve your system. So what you'll be seeing in the next day's videos is getting it into reduced row echelon form. So if there's something to write down, it's really this. So you're going to get into row echelon form, which is what I was just talking about. From left to right, getting leading zeros 1 and zeros below it. So if you did a 3 by 3, you get a 1 right here, zeros below. 1 right here, 0 below, and 1 right there. You've made your way down the staircase. You are in row echelon form. However, you haven't solved your system yet. Next, you need to get it in reduced row echelon form by working right to left, getting zeros above the leading ones. So now that we've got this thing to be a 1, now we work back up the stairs. We want to get these two to be zeros, doesn't matter the order. And then you want to get this thing to be a 0. You just want to take care of these two before you do this one. Once you've done that, now you have a nice diagonal of 1s. Everybody else is a 0, and boom, this is x equals some number, y equals some number, and z equals some number. How we're going to work through all that, I have a large collection of videos for you next time that'll take you through all of that. For now, I just want you to see all of that so we can start using these row operations next time to solve systems using matrices. Thank you for watching and have a good rest of your day. Bye-bye.